તો આપણે ટ્રી ડાયાગ્રામથી પણ જોઈ શકીએ છીએ કે ટાઉન કાઉન્સિલ આઈધર એપ્રુવ્સ or disapproves, and planning board either they have approved or disapproved. Okay, so this all are the cases. So experimental outcomes are this. So what is A1 intersection B1? I think I don't need to explain, it is very much clear from the tree that this A1 intersection B is 0.2 into 0.7. Similarly, A1 intersection B complement is 0.8 into 0.7. So do the multiplication and we will get the all these joint probabilities. So to find the posterior probability, that event AI will occur given that B has already occurred. So we apply Bayes theorem here. This is what is the equation for the Bayes theorem. This already we have discussed, right? Okay. So posterior probabilities, how to compute? Given the planning board's recommendations not to approve the zoning change, we revise the prior probabilities. So we revise the prior probabilities. So we just substitute the values. Probability of A1. What we want is A1 given B. We require probability of A1 given B. And so therefore by the Bayes theorem we substitute the formula probability of A1 into probability of B given A1 upon PA1 into PB given A1 plus PA2 PB given A2, and substitute all the values. Probability of A1 is 0.7, B given A2 is 0.2, and substitute the values, we will get 0.34. So earlier the probability of A1, what was A1? A1 was the event, let's go back our slides. What was the event A1? Event A1 was the town council approves the zoning change, and that probability was 0.7. That probability was 0.7. Now after applying the town planning board's negative recommendation, and what is the probability of now A1, that is town council approves the zoning change, this probability has been revised to 0.34. Okay, so now let us see, go back there. So therefore what is the conclusion now? The planning board's recommendation is good news for LS closures. The posterior probability of the town council approving the zoning change is 0.34 compared to the prior probability of 0.70. So that is good news for them, that the probability has been reduced. Okay, so the same problem which we have solved here by tree diagram, we can solve it through the tabular form. So firstly we will find out what are the mutually exclusive events for which the posterior probabilities are desired. So that we will find out. Those events are A1 and A2. Okay, so the second column is prior probabilities for the event. The column third is the conditional probabilities of the new information given each event. So let us find out these tables. These events are AI, that is A1 and A2, and their posterior probabilities, prior probabilities are 0.7 and 0.3, which we have already assumed, and the conditional probabilities after the town planning's decision, that is 0.2 and 0.9. So therefore now what is the next column? Column 4 is compute the joint probabilities for each event and the new information B by using the multiplication law. So that means probability of AI, B given AI, so we multiply these two, probability of AI and B given AI, and we substitute over here. So that is equal to multiply the prior probabilities in column 2 by the corresponding conditional probabilities in the column 3, that is probability of AI intersection B is equal to PAI into PB given AI. So we multiply now. So what do we get? After multiplication when we do, so we will get the joint probabilities, probability of AI intersection B. So 0.14, that is equal to this 0.7 multiplied by 0.2. Okay. Now how to obtain? We see that there is a 0.14 probability of the town council approving a zoning change and a negative recommendation by the planning board. And so this is the joint probability, that town council approve the zoning change and negative recommendation by the planning board, and 0.27 is the probability of town council disapproving the zoning change and a negative recommendation by the planning board. So this is the probability. Now the column 4 we will get the sum of the joint probabilities the sum of the probability of new information is B, probability of B. That means law of addition just now, law of total probability, Goti sir has explained us. So PB is nothing but the addition of these two, 0.14 plus 0.27. That is what is the denominator of the Bayes theorem we can get directly. This shows an overall probability of 0.41 of a negative recommendation by the planning board. So the total is 0.14 plus 0.27 is 0.41. So what does it indicate? It indicates the negative recommendation by the planning board. And therefore now in the tabular form we will obtain probability of B is equal to 0.14. So this is what is the denominator of the Bayes theorem. Now the last column is now very easy to obtain. What is that? 0.14 divided by 0.41, 0.27 divided by 0.41. So compute the posterior probabilities using the basic relationship of the conditional probability. Probability of AI given B is equal to probability of AI intersection B upon PB. So these joint probabilities AI intersection B are there in the column number 4, and the probability PB is the sum of the column number 4, right? This is my column number 4. So 0.14 is the joint probability, this probability is the total probability, okay? So the posterior probabilities AI given B is now 0.14 upon 0.41. It is clearly explained on the screen, you can see, and so total probability is 1. So this is how we can obtain the posterior probabilities using the Bayes theorem, right? Let us have another example, that a drilling company has estimated a 40% chance of striking oil for their new well. A detailed test has been scheduled for more information. Historically, 60% of the successful wells have had detailed test, and 20% of unsuccessful wells have had detailed test. Given that this well has been scheduled for a detailed test, what is the probability that the well will be successful? So we have assumed the two events, S is a successful well and U is a unsuccessful well, right? So therefore probability of S is given to you, it is equal to 0.4, 40% of the successful wells are there and 60% are unsuccessful. That is, this is known as prior probabilities, okay? So define the detailed test event as D. So we define another event, third event D, okay? So here we can use, we observe that S and U are mutually disjoint. That is what the condition Dr. Goti sir has already explained. So S is a successful, its complement is unsuccessful. So we are notation is different we have used, but you can say that this is S. So this you can, instead of U you can use S complement also, right? So that is 40% and 60%. We define another event, that the detailed test event. So the conditional probabilities are given that 60% of the successful wells have had detailed test. So therefore D given S, successful wells, that condition has already occurred, that the well is successful. So therefore conditions S and probability of D is 0.6, and similarly 20% of unsuccessful wells have been detailed test. So therefore that probability is D given U is 0.2. Our objective is to find out what is the question. Given that this well has been scheduled for a detailed test, so that means D has already occurred, detailed test. What is the probability that the well has been successful? That means S given D is my required question, okay? So how do we obtain now? We need to find out what is the probability of detailed test first of all. So directly we can apply the Bayes theorem. Detailed test is, so detailed test can occur either with successful well or with unsuccessful well. So therefore this is the denominator, D intersection S union D intersection U, okay? And that can be by the law of multiplication. We can write down D given S into PS plus PD given U into PU, and we substitute all the values, we will get the corresponding probability 0.667. So we revise the probability of success given that this well has been scheduled for a detailed test is 0.667. So earlier what was the probability of S? Was 0.4, okay? And after having detailed test, the probability of successful well is 0.667. So this is what is the beauty of the Bayes theorem, that it gives me the revised probability if any condition occurs. The same thing we can explain in a tabular form. S is a successful, U unsuccessful event. So these two are the events. Corresponding prior probabilities are available, 0.4, 0.6. Conditional probabilities are also there. So that is S given D, D given S and D given U is 0.6 and 0.2. So corresponding joint probability is obtained by multiplication of these two columns. So that is D given S, D intersection S and D intersection U, and corresponding revised probability we can obtain, right. So we have another example also. So let us take the 60% of the students of a college reside in a hostel and 40% are day scholars. 30% of the hostel students attain A grade and 20% of the day scholar attain A grade in annual exam. At the end of the year, student is selected and he has A grade. What is the probability that he is from hostel? So there are two types of students. One is a hostel students and a day scholar students. So probabilities are given. So we assume two events. A is a student attend A grade first of all. Even that's the event that the student is from hostel, and E2 is a student is a day scholar. So these are the two mutually exclusive events. So student is either from hostel or he is a day scholar, right. So probability of E1 is therefore 60 by 100, probability of E2 is 40 by 100, it is already given. Also we are given that 30% of the hostel students attain A grade. So hostel student event has already occurred. So hostel student event is E1. So therefore A given E1 is a hostel student attain A grade. So that is equal to 30 upon 100. Again it is said that 20% of the day scholar attain A grade. So therefore A given E2 is 0.2 is given, right. Now by so what is the question here? At the end of the year, the student is selected at random and he has A grade. So he has A grade. So that means event A has already occurred. Given A, what is the probability that he is from hostel? So from hostel it is E1. So E1 given A is a required question. So E1 given A. So therefore by the Bayes theorem, probability that the A grade student is from hostel is equal to probability of E1 given A, which is equal to probability of E1 into probability of A given E1 divided by probability of A. Now what probability of A is a numerator, which can be, so probability of A, that means grade A has occurred. A student has obtained grade A. So either it may be from hostel or it may be a day scholar. So probability of E1 into probability of A intersection E1 given E1 plus probability of E2 plus probability of A given E2. So we substitute all the values and simplify, we get the probability is 0.26. So now we apply the Bayes theorem. So that is equal to, in this equation, if we substitute all the values, probability of E1 into probability of A given E1, that means equal to 60 by 100 into 30 by 100 divided by 26 by 100. So corresponding probability is 18 by 26, right. So I think this is the sufficient examples we have discussed. Now if you have any kind of questions or the queries, you can ask her and call us. પટેલ સાહેબ આપ કંઈક આના વિશે વધારે જો પ્રકાશ પાડો તો આપણે ચર્ચા કરીએ ત્યાં સુધી. જો કોઈને પ્રશ્ન હોય ને ફોન કરે ત્યાં સુધીમાં આપણે ચર્ચા થોડીક ચલાવીએ.
એટલે આપણે જેમ આગળ કહ્યું કે બેઝ થિયરમ છે એ ખાસ તો આપણે એવા ઇવેન્ટ્સ માટે લગાડવો જોઈએ કે જેમાં ઓર્ડર રિવર્સ થઈ ગયો હોય. રેગ્યુલર જે ઇવેન્ટ્સ પહેલાં બનતો હોય એની પ્રોબેબિલિટી આપણે શોધવી હોય અને આપણને કોઈ પછી બનવો જોઈએ, બરાબર. એ ઓલરેડી આપણને બની ચૂકે એવી રીતે આપી દીધી હોય તો આ ખાસ સમજવાનું સ્ટુડન્ટ્સે દાખલા ગણતી વખતે કે કયો ઇવેન્ટ્સ છે, કયો કંડિશનલ તરીકે લેવો છે, કયા કંડિશનલને આપણે બેઝ તરીકે લેવો છે. હમણાં એક્ઝામ્પલમાં આપણે જોયું પ્રોબેબિલિટી E1 ગિવન એ આપણે શોધવી છે, પ્રોબેબિલિટી A ગિવન E1 આપણને આપેલી છે. તો ક્વેશ્ચન પરથી અમને ધ્યાન રાખવું પડે કે E1 ગિવન એ લખવું કે A ગિવન E1 લખવું અહીંયા આગળ.
એટલે પહેલો ઇવેન્ટ કયો અકર થયો છે એ જાણવું ખૂબ જરૂરી છે.
ખૂબ જરૂરી છે. એટલે આ બેઝ થિયરમના પ્રોબ્લેમ ખાસ આ સમજવું જોઈએ. આ સમજ્યા પછી એકવાર ડિફાઇન કરી શકશે કે ભાઈ કયા ઇવેન્ટની આપણે પ્રોબેબિલિટી શોધવી છે, કયો ઇવેન્ટ આપણને આપ્યો છે. એના પછી જો કંડિશનલ નોટેશન બનાવતા એમને આવડી જાય તો પછી બેઝ થિયરમ એમને પ્રોબ્લેમ ના રહે. બીજું
એટલે આ દાખલામાં વધારે સાહેબ ચર્ચા કરીએ તો કે સૌથી પહેલા કયો ઇવેન્ટ અકર થાય? સ્ટુડન્ટ સિલેક્શન નો અકર થાય ને,
સિલેક્શન નો થવો
બરોબર?
જોઈએ.
એટલે પહેલા સ્ટુડન્ટ સિલેક્શન નો થાય અને પછી એનો ગ્રેડ નક્કી થાય, ગ્રેડ ની વાત આવે. એટલે એ રેગ્યુલર સિક્વન્સ છે કે પહેલા સ્ટુડન્ટ સિલેક્ટ થાય અને પછી ગ્રેડ આવે.
ક્વેશ્ચનમાં આપણે ઊંધું પૂછ્યું છે
અને ઊંધો ક્વેશ્ચન પૂછ્યો છે કે સ્ટુડન્ટ હેઝ ગોટ એ ગ્રેડ, વોટ ઇઝ ધ પ્રોબેબિલિટી ધેટ હી ઇઝ ફ્રોમ હોસ્ટેલ. એટલે પહેલા ગ્રેડ આપી દીધો અને પછી કીધું કે હોસ્ટેલ નો છે કે
સિચ્યુએશનમાં આપણે બેઝ
એ વખતે બેઝ થિયરમ વાપરવો પડે. એ ક્લિયર આઈડિયા આવી
બીજું
જાય
બેઝ થિયરમમાં જે ડિનોમિનેટર છે, તમે પીએ આપણે લખીએ છીએ ટોટલ પ્રોબેબિલિટી, એના જે કમ્પોનન્ટ્સ હોય, પીએ ધારો કે બે પાર્ટ્સમાં છે, P1 ઇન્ટુ એ ગિવન ઇવન પ્લસ P2 ઇન્ટુ એ ગિવન ઇવન, તો એનું ન્યુમરેટર જે છે ને, આ જે કમ્પોનન્ટ છે એમાંથી એક કમ્પોનન્ટ ઉપર હોય. એટલે તમે જો ન્યુમરેટર લખી દીધું ફોર્મ્યુલા યાદ રાખવા, ન્યુમરેટર લખ્યો હોય તો એમાં તમે ઇવેન્ટ E1 છે એની જગ્યાએ 2 કરી દો, 2 ની જગ્યાએ 3 કરી દો, એક્સટેન્ડ કરતા જાઓ તો તમારું બેઝ ઇઝીલી તમને ડિનોમિનેટરની ફોર્મ્યુલા મળી.
પહેલા આપણે ડિનોમિનેટર શોધી નાખીએ તો વધારે ફાયદો થાય.
કમ્પોનન્ટ જ ઉપર આવવાનો છે. એટલે બેઝ થિયરમની ફોર્મ્યુલા કઈ રીતે યાદ રાખવી? ધારો કે ડિનોમિનેટર એમ થાય કે આટલી મોટી ફોર્મ્યુલા યાદ ના રહે, તો પહેલા તમારે ન્યુમરેટરને કોન્સન્ટ્રેટ કરો, એ જ ટર્મ નીચે લખી દો અને એવી જ ટર્મ ઇવેન્ટ E1 છે એની જગ્યાએ E2 E3 મૂકતા જાઓ અને ડિનોમિનેટર બનાવી દો.
એટલે આ એક્ઝામ્પલમાં આપણી પાસે બે જ ઇવેન્ટ છે, એટલે બે થી વધારે પણ આવે તો નીચે ત્રણ ટર્મ્સ આવશે.
ઉપર E1 ને A આવ્યા, E1 ઇન્ટરસેક્શન A, એટલે પ્રોબેબિલિટી E1 ઇન્ટુ A ગિવન E1 લખ્યું આપણે, પણ નીચે શું આવશે તો એ તો મૂકી જ દો નીચે. હવે E1 ના બદલે E2 કરો, E3 કરો, આ રીતે મૂકતા જાઓ અને ફોર્મ્યુલા તમે એક્સટેન્ડ કરતા જઈ શકો. તો આ રીતે તમે સમજીને કરો તો ફોર્મ્યુલા તમને ઇઝીલી યાદ રહી શકાય અને સારી રીતે તમે એપ્લાય કરી શકશો.
બરોબર છે. આઈ થિંક મિત્રો સાહેબ કોઈને કોઈ ક્વેરી લાગતી નથી તો આપણે
મિત્રો અમને આશા છે કે આ પ્રોબેબિલિટીના 3 લેક્ચરમાં પ્રોબેબિલિટી શું છે, કેવી કેવી ટાઈપની એની એપ્લિકેશન્સ છે, ક્યાં ક્યાં આપણે પ્રોબેબિલિટીનો ઉપયોગ કરીને શું ઇવેન્ટ્સની જાણકારી મેળવી શકીએ, તો તમને ખૂબ પ્રોબેબિલિટીમાં તમને જ્ઞાન પ્રાપ્ત થયું હશે. તો આ 3 લેક્ચર આપણે પ્રોબેબિલિટીના ફાળવેલા. હવે આપણે નેક્સ્ટ ટાઈમ આપણે બીજા ટોપિક્સ ઉપર આગળ વધીશું. તો આ સાથે આપણે આ લેક્ચર આપણે પૂરું કરીએ છીએ.
થેન્ક યુ ફ્રેન્ડ્સ. એટલે ફરીથી આવતા ગુરુવારે આ જ સમયે ફરીથી મળીશું, એટલે ચૂકશો નહીં મિત્રો. થેન્ક યુ વેરી મચ.